Every natural number k when y is equal to x squared minus 4x plus k minus 2 is on the fourth quadrant. The first way of solving this question. At first, let's think about the two types of our graph. And there are exactly two types of our graph, and all of them are defined by the leading coefficient. And if you think about what is leading coefficient, it will going to be the coefficient of a leading or the highest degree power. Our highest degree power in this case will going to be x squared, where it contains x squared term. And our coefficient of our highest power term will going to be 1. So our leading coefficient will going to be 1 in this case. But our leading coefficient changes depending on time. So we usually notate it as A. The reason is because when you write standard form, we usually write it as y is equal to ax squared plus bx plus c. And before we think about our two types of our quadratic function, let's think about each variable and what it stands for. At first, if you think about the y should always be the output of a specific function. And according to the output, there always should be an input, because in order to generate the output, there should always be an input. And our x value will going to be the input of our function. So we can exactly notate it in this way. So first of all, our y value will going to be the output of specific function. And for the x value, it will going to be a specific input. And the reason is because the function means it is a terms or expressions between the y and the x value. And if we have the input of the function, all you have to do is we need to input this value to our original equation, and according to the equation, it will going to generate our output of our function, which we notated as y. And let's think about what is the a. For the a value, so the a value will going to be a leading coefficient. If you think about what is leading coefficient, the leading coefficient will going to be the coefficient of the highest degree power term. And if you think about the highest degree power term in this case, it will going to be the x squared, where it contains x squared term. So in this case, the leading coefficient will going to be the coefficient of the x squared, which will going to be 1. Now let's think about what is the c. So for the c, it will going to be the y-intercept. And if you think about the definition of the y-intercept, it will going to be when the x value should always be equal to 0. Our y value, which will going to be the output of a specific function, will going to exist. And we notate it as y value because it is a variable which always change. So our y is equal to the variable. And the reason why the c value is equal to y-intercept is because we can say that our 0 is our x value, which will going to be the input of our function. If we input 0 to our function y is equal to ax squared plus bx plus c, which will going to be the standard form, it will turn like y is equal to a times 0 squared plus 0b, or we can write it as b0 plus c. When x is equal to 0, this whole term will turn to 0, and our y value will going to be c. So that's why our y-intercept in this standard form will going to be c. Now let's think about the two types of our quadratic function. So at first, there are two cases, and every cases will going to be defined by the leading coefficient. But in this case, we write the leading coefficient as a because it changes depends on time. The first case is when the a value, our leading coefficient, is greater than 0, which means when our a value is positive value, the graph of our quadratic function will open or will go upward. When the quadratic function or our function goes upward, For example, it will look something like this that keeps going toward upward, which means it never intersects at one specific point, but then it will going to contain one point, which is one of the most important thing in a quadratic function, which we call it as, or which we refer as minimum or the lowest point of our quadratic function. So when the minimum point exists, we can say that our leading coefficient should always be equal to a positive value. Now let's think about what it will going to be the second types. The second type will going to be when the a value, our leading coefficient, is less than 0. When our leading coefficient is less than 0, our graph of our function or a graph of our quadratic functions will open downward or will go downward, unlike the first case. So if the quadratic function's graph opens downward, such as it will look something like this, that keeps going toward downward, it never intersects at a specific one point, but then we're going to contain a specific one point, which is also one of the most important point in our graph, which we call it as our maximum point in our quadratic function. And for the maximum point, we also call it as the highest point on our graph. And if you think about the case where the highest point, our maximum point, exists on our quadratic function, it will going to be the case where our leading coefficient is less than 0, which means when it is negative value. Now if you think about the term vertex of our quadratic function, the vertex is same thing with adding the number of possibilities of the minimum point, the number of possibilities of the minimum point, and the maximum point. And that we're gonna call it as the vertex of our quadratic function, which is one of the most important or the most important terms that we need to know in the quadratic function. Let's go back to our original question. The most important term in this question will going to be the vertex of our quadratic function. And the way that I'm doing right now will going to be the first way to solve or approach this question. So our vertex is the most important term in this question, which means right now the graph of our quadratic function is referred to be a standard form. And the standard form is optimized when it comes to solving for the y-intercept, which means it is not that important when it comes to solving for the vertex. So we need to kind of convert this into some specific point, or the function, or the form. The most important form in order to find the vertex, our vertex of our quadratic function, will going to be the vertex form. If you think about what is vertex form, it is same thing with completing the square, which means it is same thing with the perfect square form. This is what the vertex form is. And the vertex form is optimized when it comes to solving for the vertex of our function. So at first, our first way to approach this question is to convert this into a vertex form. So at first, let's actually write our function down again. Our function was y is equal to x squared minus 4x plus k minus 2. The most important thing to know in our function in this case will going to be the k, because it will going to be our ultimate value that we want to solve in this question. So at first, let's convert this into our vertex form, which is same thing with making into a perfect square form. So at first, if you do it, it will look something like this. Y is equal to x squared minus 4x, and if you think about the constant that we're going to come out, which is same thing with the constant in our equation, we're going to be, according to our formula that we did in a lot of videos, it is same thing with taking a half of our coefficient of the first power term and square it, which will going to be the positive 2. So this will going to be in our parenthesis, which is the most important thing in our perfect square form. But then we still have our leftover. We have k minus 2. So we have k minus 2. The one thing here, according to our formula, we need to take half of this and then square it to make the perfect square form. But since we added 4 in order to not affect our quadratic function, we need to subtract 4 in front of or behind our parenthesis, not to affect our original function. All you have to do now is we need to make this term inside the parenthesis into a perfect square form, because that is the whole point of converting this into a perfect square form, or converting the square. So it will gonna be x minus 2 squared. If you want to get our original function, all you have to do is extend our terms. But then we still have our terms, our coefficient, our constant. It will going to be positive k plus k. Minus 2 minus 4 will turn to negative 6. This will going to be our vertex form that we found. So this will going to be our vertex form, which is the first way to approach this question. But in the next video, it will going to be whole different with this kind of types. Now, let's think about our vertex point. But since we knew that there are 2 cases in our vertex, there is a minimum point and a maximum point. But if you think about our leading coefficient is a positive value, which means it will go to vertex of our function, will going to be the minimum point in our quadratic function. So our minimum point in our quadratic function, as we have learned a lot of videos, will going to be 2 comma our leftover, which will going to be our constant, k minus 6. This will going to be our minimum point of our vertex in our quadratic function. 2 comma k minus 6. And now we need to go back to our original question. The vertex of our quadratic function is in the first quadrant. Our first quadrant is right over here, where the x value is positive, and the y value is equal to negative. So if you think about it, we don't have to draw a graph perfectly. All we need is whether it goes upward or downward, and the location of our vertex when it comes to solving this kind of questions. So I will just put a vertex in anywhere in our first quadrant, and I will just draw it. So it will look approximately like this. We don't really need the x and the y axis in order to solve for this question. And now let's think about this in this way. So we can think about it in this way. In the first quadrant, if you think about this properly, so the first quadrant will going to be when the x terms or the x-axis is positive, but our y axis will going to be negative, which means our output of our function, which will going to be the y value, is also going to be negative. So our y value, which will going to be k minus 6, our y value that includes the unknown variable, which will going to be k. So k minus 6 will going to be our y coordinate of our vertex, and it should be less than 0, which means it should be negative. There will going to be a whole bunch of k values if there is no range of k. So let's think about the range of our k value. Let's go back to our original function. It says k should be the natural number. And this is a case where we need to think about what is natural number. What is natural number? What is natural number? Natural number will going to be the positive numbers. So natural numbers will going to be the positive numbers. If you want to notate this simply, if you want to notate this statement simply, it can be in this way. I'm gonna simply notate number as n. It should always be greater than 0. This is what the natural number is. So our k value should be always greater than 0, since we knew that k is equal to a natural number. A natural number is just a number, not a decimal, not a fraction, just a number that is positive. So k minus 6 should be less than 0, which means we can think about k as 1, 2, 3, 4, and 5. If we input these values to our k, you are going to make our range k minus 6, which will going to be less than 0. So our answer for this question will going to be k is equal to 1, 2, 3, 4, 5. And these are the natural numbers in our equation. And in the next video that we're going to connect with this video, we're going to be the same exact problem, but another way, the simpler way to approach it in my perspective.